Oh boy, you look at this one here and right away you see all these fractions, so it's a little intimidating, but we know that you can eliminate all those fractions with just a multiplication. Let's number these, 1, 2, and 3. Now let's eliminate all the fractions by finding LCDs and then multiplying through. So in problem number, in equation 1, what is the LCD? Now you might be able just to do this in your head, but I'm going to write it all out. So 6 times 1/3 x plus 6 times 1/2 y minus 6 times 1/6 z equals 6 times 4. All right, now 3 into 6 is 2. Right, I'll write that. 3 into 6 is 2, and then you get the 2 times 1, which is 2x. So you get 2x plus, now let's just do this one here. 2 into 6 is 3. 3 times 1 is 3, so you get 3y minus, these 6's are going to cancel, right? And you're just left with what? 1z, or just z, equals 24. Okay. Now this is, I'm still going to call it equation 1 because it really is equation 1, just a different multiple. Now for equation 2, what's the LCD here? The LCD in equation 2, let's look at it, 4, 4, 2, and 2. LCD is 4. So I'll multiply everything up here by 4, right? Run a 4 here, run a 4 here, 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 and here. So I'll write it. So writing that, we're going to get 4 times 1/4 x minus 4 times 3/4 y plus 4 times 1/2 z equals 4 times 3/2. And then these denominators will cancel, right? The 4's cancel and you just get 1x, or just x, minus those 4's cancel. You get 3y plus, now what happens here? 2 will go into 4 twice. 2 times 1 is 2, so you get a 2z equals, and then 2 will go into 4, sloppy 4. 2 will go into 4 twice. 2 times 3 is a 6. Okay, I'll circle that so I can find it. And that's going to be our equation 2. Just a different form of equation 2. And for equation 3, the LCD here, that looks to me, okay, well, what do we have? 2, 3, 4, and, well, it's not 4, it's not 6. How about 12? All three of these go into 12. So let's make it 12. Put a 12 in front of every one of those original terms. 12 times 1/2 x minus 12 times 2/3 y minus 12 times 1/4 z is equal to 12 times negative 16 over 3. Let's divide. So 2 into 12 is 6. 6 times 1 is 6, so we'll get 6x. 3 into 12 is 4. 4 times 2 is 8, so 6x minus 8y. And then this, I'm over here now. 4 into 12 is 3. 3 times 1 is minus 3z is where we are, equals, and then 3 into 12 is 4. 4 times negative 16 is negative 64. So negative 64. And there's our equation 3. So now we are looking at this system here. 2x plus 3y minus z equals 24. Second equation is x minus 3y plus 2z, that's equal to 6. And the third equation, 6x minus 8y minus 3z is negative 64. There's equation 1, equation 2, equation 3. So I'm going to eliminate, now I just eliminate z, that's just what I do. Eliminate z using, how about 1 and 2 first, right, and then I'll use 1 and 3. So first of all, just using 1 and 2. Well, to eliminate z, focus in on those coefficients. The smallest number they go into, I got a 1 and a 2 is 2. All I have to do is multiply this top equation, number 1, by 2. Right, they're already opposite signs. So here's the plan. Well, I'll get the same color here. 2 times equation 1 and then add it to equation 2. No multiplication necessary because it's already a 2. Looks like this. Multiply everything in equation 1 by 2. So 2, 2, 2, 2. All right, so we're going to get what? 4x plus 6y minus 2z equals 48. Equation 2 stays the same. X minus 3y plus 2z, that's equal to 6. Add these together, we're looking at 5x plus 3y, the z's are gone, equals 54. Okay, so let me circle that so I can find it again. And I'm going to name that equation 4. Well, this is kind of a mess. I'm not sure what happened there, but I'm going to call that equation 4. All right, now let's eliminate z using 1 and 3. All right, so now I'm going to use 1 and 3. So focus in on these coefficients. I got a negative 1 and a negative 3. They're the same sign, so I need a negative multiplier, and I'm going to multiply by 3. So my plan is this. Negative 3, oh, let's get the same color here. Negative 3 times equation 1 plus equation 3. So let's do this. Let's multiply a negative 3 through every one of those 4 terms in that first equation. How about negative 6x minus 9y plus 3z equals negative 72. Equation 3 stays the same. 6x, oh, that's interesting. The x's are going to go out also. Minus 8y minus 3z is equal to negative 64. Add these together, it looks like the x's are gone, the z's are gone. Negative 17y is equal to negative 136. So y is negative 136 over negative 17. And that turns out to be an 8. So I've got y. Okay, now you know what? We've got y. Why don't you just come right back here and put that y right in there? So if we do that, we'll get this. 5x plus 3 times the 8, that's 54. So 5x plus 24 is 54. Subtract. We'll get 5x equal to 54 minus 24 is 30. Divide, x is 6. So now we've got x, we've got y. Just find an equation that has a z in it. You know, I'm going to come back up here, and I think that might be the easiest one because it's just negative z. I don't have any multiplier. So I'm going to substitute these into equation 1. Now I'm going to say what it is I'm going to do, then I'll do it. So what I'm going to do, I'm going to take that 6, substitute it for x in equation 1. So I'm going to put a 6 right there. And then we got an 8 for y, so I'll put a 6 here, an 8 here, and we'll solve it for z. What do we get here? It's going to be 2 times 6 plus 3 times 8 minus z is 24. We get 12 plus 24 minus z equals 24. Right away, if I subtract 24 from each side, we'll get simplification here. So 12 minus z is 0. Why don't I just take that to just add it to both sides. 12 is equal to z. All right, so let's summarize. Here's what we have. X is equal to 6. Y is equal to 8. Z is equal to 12. We can write it like that. Or, if you like, an ordered triple as 6, 8, and 12, signifying where these 3 planes intersect.